Hi, this is Professor Pradyot from Leadib Academy. We are looking into the IBDP Chemistry SL Paper 2 of November 2019. We are looking into the video solutions, but importantly, it is not going to be only the video solutions, but we'll be understanding the underlying concepts. So you will have a deeper understanding of the concepts. Okay, so it would be more some kind of a revision, okay, of those concepts, and you will get a better clarity. And definitely, if you are interested in having more detailed understanding of these concepts, please do visit our website, because we have uploaded the courses of chemistry, physics, math. Okay, so please do visit and subscribe to our courses. Lovely. Okay, now let's begin with this question number 3 from organic. Appears to be very interesting. So let's start. So they have given us this reaction, ethene, C2H4, getting converted into C2H5Cl, getting converted into C2H6O, and then C2H4O. Asking the question, state the type of reaction which converts ethene into C2H5Cl. So let's begin our story. So first thing first, get understanding, okay, what kind of a reaction ethene okay, and getting reacted with hydrogen chloride. Okay, let me show a little differently. Hydrogen chloride, I'll show with the different colors. Okay, hydrogen chloride. We know there is slight polarity. Okay, it's a polar molecule. So there will be delta plus and delta minus. Okay, now what happens in case of this ethene? Okay, this double bond where it is a pi bond, so pi bonded electrons are delocalized. Okay, they are quite loosely bonded, so they can, because of the weaker bond, so they will get shifted to one of the carbons. Okay, so let's see what structure we will get. So we will get something like this: H, 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 okay. So this carbon will turn out to be negative. It will develop a minus charge. This carbon has lost the pi electrons, so it will have a delta plus. And now you people have smartly understood that what is going to happen, that Cl minus is going to come and get attached, and here H plus will come, and we will get this compound. So what is important now? So what has happened is that there was a lot of electron density, high electron density zone. Okay, high electron density zone because of this pi electrons. So it means it is rich in electron. So who is going to attract? Obviously, it is nothing but an electrophile. This is electrophile. Why electrophile? Because there is a deficiency in electron on this H plus. Okay, so it is basically going to get added, and that's why this is called electrophilic addition. Across the double bond, HCl or electrophile has bin added. Electrophile is the species which is deficient in electrons. Phile means love, and nucleophile means the one which loves nucleus. Nucleus means positive charge. That means they are rich in electron. Okay. So it is very, very simple. So this reaction is nothing but electrophilic addition across the double bond of alkene. Simple. Let's look into the question number 3b. Write an equation for the reaction C2H5Cl with aqueous sodium hydroxide to produce C2H6O compound, showing structural formulas. Okay, now let's understand structural formulas. So important to show like this. Okay. Let me show with the different color. Okay. This is called chloroethane. And then NaOH. Okay, aqueous means we are talking about OH minus. Okay, and there is a heat. Now what is going to happen? Interesting part. Please understand that OH minus, it's a negative radical. That means there is a extra electrons. It is rich in electron. And this is what we call a nucleophile. Okay, nucleophile. So this nucleophile, being rich in electron, it is looking into some species which are deficient in electrons, poor in electrons. So what is going to happen? Very, very simple. Please understand that this is the chlorine which is attached. So chlorine can leave. Okay. So let's understand it with the structural formula. So HCH. Okay. So this chlorine has left. Okay. Chlorine has left as a chloride radical or chloride ion. That means it has taken the electron from this poor carbon. Now carbon has become deficient. That means it will have a delta plus charge. It means this has now become a deficient. That means now this has become basically electrophile. Okay, this carbon ion, okay, and this is called a carbocation. That means the carbon carrying a positive charge. Okay, it is extremely reactive because carbon is now desperately looking that someone should come and attack and put the electrons. And who is that? So here comes this OH, okay, which is going to come and attack this carbon. So exactly OH will come and get attached because OH was rich in electrons. Okay, and so we will get this compound, and you people have smartly guessed it. This is nothing but ethanol. Okay, and for your information, even though it was not asked, but you can understand that this is nothing but nucleophilic substitution. Why nucleophilic substitution? Simple, because the reagent, that is OH minus, which is coming from NaOH, was rich in electron. Okay, that means it is looking for the nucleus. Nucleus means positive charge, and here comes the carbon, which was having a positive charge. It had become carbocation after leaving of the Cl minus, and so it get attached. And that's why this is called a nucleophilic substitution. Extremely simple concept. So we get basically ethanol. Very, very simple. Okay, it's an alcohol, OH. Okay, question number 3C1. Write an equation for the complete combustion of the organic product in B. So what was the organic product? It was nothing but ethanol. Okay, so they are asking us combustion of alcohol, that is ethanol. Simple. So how to do it? So what is the combustion? Combustion means we have to react with oxygen, complete combustion. Okay, that is important. So whenever it is a complete combustion, we have to get CO2 and we need to get H2O. Always remember, for complete combustion, the products of combustion are carbon dioxide and water. Now it may look a little bit confusing how to balance this. So I'm going to give you the simple trick, okay, or remember it as a formula, okay, whatever you can think of. So first write down this compound, alcohol. It would be always C, H, and O, and let me write its coefficient. Those are X, Y, and Z. Now what is the formula? So the formula for this, it will be reacted with X plus Y by 4 minus Z by 2, okay, and then oxygen, and then extremely simple, X amount of CO2 followed by H2O, which is of Y by 2. Okay, so please remember this as the equation for combustion of any compound, that is CXHYO. So for this, our given example, C2H5OH obviously can be written as C2H6O. Now tell me, what is X? In this case, X is equal to 2, Y is equal to 6, and Z is equal to 1. So let's substitute directly and try to get the equation. So in this case, it is C2H6O plus, what is X? 2. How much is Y? So that is 6 by 4 minus Z by 2, oxygen, giving us X of CO2, that is 2 of CO2, plus Y by 2, that is 6 by 2 H2O. So let's recalculate this. Okay, this will be 2 minus half, that is, okay, that is going to be 3 by 2, and even this is going to be 3 by 2. So 3 by 2 plus 3 by 2 is going to be 3. So 3 oxygen, giving us 2 CO2 plus 6 by 2, that is 3 H2O. And our complete equation is this. So you don't need to really balance if you remember this formula. Okay, very, very simple. Okay, and remember that I have discussed this formula and similar kind of a combustion formula, which are very, very useful and very fast. Okay, I have discussed this in detail in our courses, so please do subscribe to our courses, and which we are uploaded on our website, Leadib Academy, okay, .com. Hope this is quite clear and very simple also. Let's look into the question number 3C2. Determine the enthalpy of combustion of the organic product in B in kilojoules per mole using the data from section 11 of the data booklet. Okay. So I just kept this ready, okay, because we know how to calculate the enthalpy of combustion. Okay, so what we are going to do, very, very simple. we are going to look into the various kind of bonds. So first, please remember as a concept that always in the reactants, the bonds are getting broken. Okay. In the reactants, okay, and this part, the bonds are going to be broken. And in case of the products, the bonds are getting formed. And finally, the delta H of combustion, enthalpy of combustion, is going to be bond, okay, what are basically getting broken minus bonds which are getting formed, okay, enthalpy. Please remember, whenever bonds are getting broken, you need to supply the energy, while when the bonds are getting formed, because it is a more stable state, the energy is being released. That's all. Okay, so let's now look into it. So let's identify how many types of bonds are there. So we can easily see in case of the ethanol, that is C2H5OH, how many types of bonds are there. So we can first of all see very clearly that there are 5 numbers of CH. Okay. Then there is 1 number of C and C bond between carbon and carbon. Then 1 number of carbon and oxygen, and 1 number O and H. Simple. Okay. And then in case of, okay, so this takes care of ethanol, and in case of oxygen, there are straightforward 3 numbers of O double bond O. Okay, that's all. So now what we will do, we will pick up this from the data table. Okay, so I'm just seeing whether it can be zoom out, and then we'll start writing. Okay. So can we see single bond between carbon and hydrogen? So carbon here and hydrogen, that is 414. So let me put it 5 multiplied by 414. Then 1 number of C and C, carbon and carbon, that is 346, plus 1 number of carbon and oxygen, carbon and oxygen, that is 358, that is 358, and plus 1 number of OH, oxygen and hydrogen. Oxygen and hydrogen, that is 463. So this takes care of ethanol. And now moving on to the oxygen, there are 3 numbers of O, double bond O. We can clearly see that 498. Take out your calculator and let's calculate. Okay. So this number works out to be 4731 kilojoules per mole. Okay, very simple. So just remember this, or I'll write it down somewhere. 4731 kilojoules per mole. This is what is required to break the bonds, okay, in the reactants. Now let me just clear this and then put for the products. Okay. So now coming to the product side, we can see that in carbon dioxide, each carbon molecule will have 2 C double bond O. So since we are talking about in the balance one, there are overall 2. So that means 4 C double bond O. So let's look into the C double bond O. Okay, that is 4 into 804. Okay, and then O and H single bond, H and O, that is 463. So 6 into 463. Let's take out the calculator and do the calculation. Okay, so this will give us 5994 kilojoules per mole. Okay, and so now what is the delta H for the combustion? It's simple. Bond broken minus bonds formed. Okay. So bonds broken were 4731. Bonds formed energy, just now we calculated 594. Okay, you do this calculation, you should be getting the answer. Okay, so it was a very good quality question for understanding how to calculate the enthalpy of combustion. Okay, so you should be identifying all the bonds which are getting broken and formed. So important is that you should be knowing the molecular structure of these important compounds. Okay, it is expected that you should be knowing, and that's why, because without knowing it is virtually impossible to calculate, because we should be in a position to understand which bonds are getting broken, which bonds are getting formed. Simple. Okay, and then the formula is very, very simple, and we can take the help of data booklet, okay, to calculate this. Hope this is quite clear and interesting. Okay, question number 3D1. Interesting question. State the reagents and the condition for the conversion of the compound C2H6O produced in B into C2H4O. So let's try to understand what is going on in this. So we got this in B, H, and then OH. Okay, this is nothing but our ethanol. Now we need to convert it into C2H4O, and you people are smart enough and have understood already that what kind of a substance we are talking about. Okay, so we are talking about, okay, a strong oxidizing agent. Okay, but important that this has to be acidified. Okay, If you are not satisfied, you don't want to give K2Cr2O7, that is a potassium dichromate, or you can give potassium manganate, KMnO4. Again, this has to be acidified. Okay, so this can be or, and then you distill off. So what we will get is this straightforward ethanol. So that is this ethanol oxidation. Okay, so I think let me put it in the different color, the functional group, so that you will understand much better. So that is C double bond OH. Okay, this is aldehyde group. Okay, functional group, and this is basically ethanol. Okay, so this is the oxidation. And so what were the reagents? Reagents were potassium dichromate or KMnO4. If you want to give it in the different way, okay, you just want to write it in the ionic form. So this can be written like Cr2O7 2 minus or MnO4 minus. Okay, the choice is entirely yours. And then you distill off. Okay, so that we will get this ethanol. Very, very simple. Okay, oxidation of alcohols, and importantly primary alcohols. Okay, that should be very clear, because ethanol is primary alcohol. If you need any kind of a detailed understanding, okay, of this, or more deeper understanding, please do visit our website, okay, leadibacademy.com, where we have uploaded the courses for chemistry, physics, maths. Okay, interesting. Okay, so continuing with 3D2, explain. Okay, let me make it very clear that this we are referring to is the 3D2. Explain why the compound C2H6O, that means they are asking about this, okay, produced has a higher boiling point. Okay, so in terms of the boiling point, this is having higher boiling point than this. Okay, that's the question in terms of the boiling point. So what do you think? What could be the answer? Very, very simple and conceptual. We know that in this case, hydrogen is attached to second most electronegative atom, that is oxygen. So oxygen is electronegative, so it is a very greedy for the electron cloud. So it is going to grab the electron cloud in this covalent bond with the hydrogen, and poor hydrogen is basically becoming positive because it is deprived of the electron cloud. Okay, and in case of this ethanol, there is only the double bond. Okay, that is basically having a slight polarity. But please remember, this means that this H plus is capable of forming hydrogen bond. Okay, this is going to form hydrogen bond with the other molecule of ethanol. Okay, so this, because whenever, please remember, whenever hydrogen is attached to three most electronegative elements in the periodic table, that is FON, at some extent even Cl. Okay, but mainly FON, fluorine, oxygen, nitrogen. So without thinking, Cl we cannot really consider, mainly it is FON. So in this case, hydrogen is connected to the oxygen, straightforward. That means this is the case of hydrogen bonding. That means while getting connected to the second molecule of ethanol, there will be a very high amount or very strong bond between two molecules, and we call that hydrogen bonding. These are IMF, intermolecular forces. They are the strongest, and if the higher the IMF, okay, see, higher the IMF, higher is going to be boiling point. Simple. So what is important is that it basically whether that compound is capable of forming hydrogen bond. Okay, while in case of this ethanol, there is no possibility of hydrogen bonding. Okay, because oxygen or the hydrogen is connected to this poor carbon, which is not electronegative at all, almost similar kind of electronegativity, while oxygen has been double bonded with carbon, so it will make a slightly polar, but they are not capable of forming hydrogen bond. Very interesting and important. Hope this is quite clear. Simple. Okay, 3E. Ethene is often polymerized. Draw a section of the repeat resulting polymer showing two repeating units. Let's see. So first of all, ethene, double bond, this. So we know very well that this double bond will get opened up. Okay, it is like this, and it will result into C H C H H, and I'm purposely showing the continuation bonds. Okay, and then you can think of another molecule similar type of ethene which has also undergone opening. Okay, and so these are the continuation bonds. So this is monomer 1, this is monomer 2. And now what is going to happen, that they are going to get attached, and finally we will get like this, C H H is one unit and second unit. Okay, but most importantly, we need to be very careful about showing this continuation bond. Okay, so this is what is going to be the repeating units. So two repeating units, this is one and this is second, and they have been clubbed like this. Okay, very simple, because they get attached like this, these two units. Okay, very simple. Hope this is quite clear. Very simple, interesting.